Assalamu alaikum. It's me, your chemistry teacher, Ms. Faratiba from Peshawar Model School, Nashara branch, and today I will give you the lecture number 2 of Chemical Equilibrium, chapter number 9 of Chemistry class 10th. And today the topic of our lecture is the reversible reaction and dynamic equilibrium. But before going to start our lecture, I would like you to subscribe our YouTube channel so you will watch our videos continuously on our channel. Okay, let's come to our lecture. Here is the two terminologies and we will discuss both of these one by one. First one is the reversible reaction. As the name indicates, the reversible means that any process that can be reversed in the backward direction, or we can say that those reactions which proceed both in forward and backward directions are called reversible reaction. Or we can say the reaction that does not go to completion and the products formed reacts to form the reactants back is called reversible reaction. Okay, what does it mean by this sentence? The reaction that does not go to completion. It means that when the reactants are reacting together and the products are formed, so it doesn't mean that all of the reactants are consumed for the formation of product, but it means that after some time, when the reactants are decrease in concentration, so after some time the products are formed and products are reacting back and will give us the reactants in the backward direction. So it doesn't means that all of the reactants are consumed. It means that there must be came the equilibrium stage, so at that stage the backward reactions start, and that is called the reversible reaction. Or we can say there must be attain dynamic equilibrium in this reaction. Okay, how we can represent the reversible reaction? Reversible reaction can be represented by two arrows between reactants and products. The double arrow indicates that at equilibrium state the forward and reverse processing occurring at the same time. The forward reaction take place from left to right and the reverse reactions takes place from right to left. Let's take simple example of reversible reaction. This is the most simplest reversible reaction. When we give heat to the water, it start evaporating, and in the forward reaction it will gives us the vapors, or we can say the water convert into gaseous form, and when these vapors condense into liquid water, it will comes in the backward reaction, and this is the reversible reaction, because we know that any reaction in which the forward and backward reactions occur at the same time are called the reversible reactions. Okay, these are some more reactions, or we can say the examples of reversible reaction. When nitrogen gas react with the hydrogen gas, it will gives ammonia in the forward reaction, because this is the product, and when these products react back, it will gives us the same reactants, nitrogen and hydrogen gas. So this is the backward reaction, and this is the overall reaction, nitrogen and hydrogen reacting together, and it will give the product, and these products dissociate and will give back to the nitrogen and hydrogen. So this is the reversible reaction. Okay, next is the mercuric oxide. Let's suppose we take this mercuric oxide in a closed test tube and give some heat to that test tube, and the mercuric oxide is in the solid form, and when this mercuric oxide decompose, it will give us the mercury and oxygen. Although at the start the concentration of mercuric oxide is much more than the mercury and oxygen, but after some times, when the concentration of this mercuric oxide becomes lesser in amount, the mercury and oxygen becomes increase in the concentration, and after some time when these products react back and will give the mercuric oxide, so at that time at that after some time there must come the equilibrium point, or we can say that after some times the concentration of both reactants and products becomes equal, and that point is called the chemical equilibrium, or we can say there is the reversible reaction, because we know that reversible reactions are those reactions in which the forward and backward reactions occurs at the same time at the same system, or we can say that the rate of reactions become equal to one another. Okay, reaction number 3. When the sulfur dioxide react with oxygen, it will give sulfur trioxide, and when this sulfur trioxide decompose, it will give us sulfur dioxide and oxygen in the backward direction. And this is the overall reaction of sulfur trioxide formation, and when this sulfur trioxide react back, it will give the sulfur dioxide and oxygen. Okay, now let's come to reaction number 4. As you know that this is acetic acid and this is the ethyl alcohol. When these two reactants react together, it will give us the ethyl acetate and will gives the water in the forward reaction. Do you know how these two reactants reacting together? Okay, this is the for your convenience, for your easiness, I put these arrows so you will understand, and if you have any difficulty in understanding this mechanism, you can ask me in the comments. So I will give you the explanation or the mechanism of this reaction. If we break down this reactant acetic acid, so it will divide into ionic form. So and this will be the acetate ion, this will be the hydrogen ion, and when we put ions in this reactant, so this will be the hydroxyl ion and this will be the ethyl ion. Okay, and when this hydroxyl ion take on this proton, so it will comes in the form of water, and when this acetate ion take on this carbocation, it will be convert into the ethyl acetate and water, and when this product react back in the backward direction, so here is also two ions, one is the acetate ion and one is the carbocation ion, and also when we break this water into ions, so one will be the hydroxyl ion and one will be the proton. So if we put arrows, so these electrons will take on this hydrogen ion and these electrons will take on this carbocation. Do you know what does it mean by these negative and positive ion? This negative ion means that there is more electrons. So electrons are represented by negative ion and protons are represented by positive ion. It means that here is lesser electrons, so it means that there will be positive ion, and this negative ion means that there is more electron than this, so this will be negative ion. So when this negative ion attack on this opposite charge proton, so it will gives us the product of ethyl alcohol, this one ethyl alcohol. And when this negative charge attack on this proton, so it will gives back the acetic acid. Okay, this is the backward reaction, and And if we write the overall reaction, so this is the overall reaction. When acetic acid react with ethyl alcohol, it will gives us the ethyl acetate and water. This is the reversible reaction. Okay, now what is irreversible reaction? Those reactions in which the products do not recombine to form the reactants are called irreversible reaction. It means that there will be no reverse reaction, or there will be no recombination of products for the formation of reacts in the backward direction. So this will be called irreversible reaction, means there will be completion of reaction. Let's suppose this is the example of magnesium plus hydrogen chloride. When these magnesium react together with hydrogen chloride, it will give us the magnesium chloride. Okay, here is some mistake. Okay, this will be the magnesium chloride. Sorry, I will put this 2 moles of magnesium chloride, and one is the hydrogen. Okay, now let's come to the other topic, or we can say the other part of our topic, the dynamic equilibrium. Okay, in reversible reaction, when the rate of forward and backward reactions becomes equal, is known as dynamic equilibrium. As we learned before, that any reaction where the forward and backward reaction will be at the same rate, so that will be dynamic equilibrium. Or we can say that dynamic equilibrium occurs when the chemical reaction proceed, but the amount of products and the reactants remain constant. What does it mean by this? Any reaction where the reaction proceed both in forward and backward direction, but the amount of products and the reactants will be same, means there will be no decrease in on any side, means it means that equilibrium stage will be attained at that time when the concentration of both reactants and products are same. So after that we can say that that is equilibrium, or we can say that that is dynamic equilibrium. Okay, it occurs only in the reversible reaction, because as we said that in irreversible reaction there will be no backward reaction, and there will be completion of reaction. So dynamic equilibrium will occur only reversible reaction. Let's suppose this is the example of reversible reaction. When hydrogen react with iodine, it will give us the hydrogen iodide, and when nitrogen react with oxygen, it will give us this product, and when this product react back, it will give us these reactants. Okay, this is the graphical representation, or we can say the explanation of dynamic equilibrium. Let's look at this graph. Here is the two axes. On the horizontal we put the time, and the vertical in we put the concentration. Okay, now look at these curves. This curve shows that this is the reverse reaction, and this curve shows that this is the forward reaction. Forward reaction means that these two reactants will react together and will give us these two products. This is the reaction. When these reactants A plus B react, it will gives us the product C plus D. It will be the forward reaction, and when these products react back, it will gives us these reactants, so this will be the backward reaction. Okay, when these reactions start and when these A and B reacting together, at the start the rate of reaction a little bit higher, but with the passage of time the rate of forward reaction becomes decreases, and the and at this point at this point the rate of reverse reaction increases as we go upward, so the rate of reverse reaction will be increases and the rate of forward reaction will be decreases. So this point is the equilibrium point when the rate of forward and the rate of backward reaction will be equal. So that point is the dynamic equilibrium. It means that the concentration of both reactants and product at this point will be equal to one another, and after that there will be the establishment of dynamic equilibrium.